The transition is to now go from the intersection and union of sets to the intersection and union of compound inequalities, meaning we're going to have two inequality statements like x plus 1 is less than or equal to 9 and x minus 2 is greater than or equal to 3. So we'll know this is an intersection because of the word and. Or you'll have 2x greater than 4 or 3x minus 6 less than 5, a union, right? So we're going to have two inequalities linked by a connective word, and this is called a compound inequality. So the first thing we're going to look at is intersections. So we're just going to look at compound inequalities with the word and. To solve these, your first step will be to solve and graph each inequality individually. I do them both on the same number line, but them each individually. And then we'll look at how to solve them. So, step number 1. In this first question, we need to graph x is greater than -3 and x is less than 5. We're going to start with the fact that the number -3 is smaller, so we're going to put it on the left, and the 5 is bigger, so we're going to put it on the right. When I'm graphing x is greater than -3, that's going to be a round bracket, I had to think about that word for a second, and then greater than's an arrow going to the right. So these are all the values that are greater than -3. Then I'm going to graph all the values that are less than 5. So I'm just going to use a different color. If you don't have one, that's okay. But I'm going to put a round bracket opening to the left at 5, and then I'm going to draw an arrow to the left because left is less. So that's step number 1. So step number 1 is to solve and graph each inequality. Then in step number 2, because it's the word and, the only values that satisfy both equations are where the graphs overlap. So if you think about it, over here, these numbers would only satisfy x is less than 5 because they're not less than 5 and greater than -3. The values in here, like a 0, is greater than -3 and less than 5. Whereas up here, a value like 6, sure, it's greater than -3, but it's not less than 5. So the only things that satisfy both are where the graphs overlap. So then you take this part of the graph and you say, okay, from -3 to 5, you will have numbers that satisfy both equations. All right, let's move on to the next one. So for this one, again, you're going to start with a number line. -3 is smaller than 5. And then if I graph x is less than -3, that's going to be an arrow opening to the left. If I graph x is greater than 5, that's going to be an arrow. Oh, I was using a different color, wasn't I? That's going to be an arrow opening to the right. Do these two graphs overlap? Right? Is there anywhere that the two graphs overlap? No. These numbers are less than -3, but they're not greater than 5. These numbers are greater than 5, but they're not less than -3. And then these numbers in here don't satisfy either. So for this one, there is no solution. So the graph would be empty, and then you would say that there is no solution. I should be consistent with my colors. There is no solution to this inequality. And so this is the interval notation, right? There's nothing there. It's void. All right, what about the next two? The next one, look at that, same numbers. So what I'm doing is I'm showing you every single scenario you can come across. So this one is when the arrows are pointing towards each other. This one's when the arrows are pointing away from each other. And now this third one, again, we've got this -3 and we've got this 5. And we sketch it. We're looking at the x values that are greater than -3, which is an arrow going to the right. But then we also want x values that are greater than 5, which is also an arrow pointing to the right. So where do my graphs overlap? In here. All of these values, if I check a value like 6 or 7, it's greater than -3 and it's greater than 5. A number in this section, something like a 0, is greater than -3, but it's not greater than -5, so we are greater than 5, so we can't count it. And then the same thing with the numbers to the left of -3, something like -4. -4 isn't greater than -3 or greater than 5, so Done. So my solution is only going to be all these values where the graphs overlap. So it's going to be everything from 5 to infinity in interval notation. All right, last one. For this last one, this is the last scenario you can have. So we still have -3, we still have 5. These are x values that are less than -3, so round bracket with an arrow pointing to the left. And then the other one is x values less than 5. So round bracket, arrow pointing to the left. Now where do these two graphs overlap? Here. This is where they will be less than -3 and less than -5. Whereas a value like 0 would be less than 5 but not less than -3. A value like 6 wouldn't satisfy either. So for this one, the overall graph will just be from -3 down to -infinity. So in interval notation, it would be -3 down to -infinity. So these are your 4 scenarios. One, where the arrows point towards each other, and then it's that middle overlapping. 2, when the arrows point away from each other, in which case there's no overlapping. 3, when the arrows point in the same direction. Now, if they both point to the right, it'll be the greater number. And then number 4, if they both point to the left, then it'll always be less than the smaller number. All right, 2 more examples that we're going to do from scratch. So for these ones, not only do you have to graph them, but you have to solve first. So sometimes you'll end up with an inequality you have to solve. So we're going to solve that just by subtracting 3, subtracting 3. I get x is less than or equal to -2. For this one, I'm going to add 4, add 4. I end up with x is greater than or equal to -8. Then I'm going to sketch these two inequalities. Now here's the very important thing. Which number is smaller, -2 or -8? So even though you solve this one on the left, right, x is less than or equal to -2, -8 is smaller. So put the -8 over here, put the -2 over here. Always make sure they're in the order of the number line. Then we're going to graph this. This is x is less than or equal to -2. So I'm going to use a square bracket, and I'm going to draw my arrow to the left. For the other one, we have x is greater than or equal to -8. So we're going to have a square bracket and an arrow pointing to the right, which is greater. Where do they overlap? This is one of those scenarios where they meet in the middle, right? So they overlap each other. So my solution to this one would just be -8 to 2, right? Just that place in the middle. All right, if you're feeling good about this, maybe pause the video and give the next one a go. So if I'm going to minus 4x minus 4x, I end up with -2x is less than or equal to 8. I'm going to divide both sides by -2. When I divide by a negative, I'm not going to forget to switch my inequality sign. So I end up with x is greater than or equal to -4. For this one, I'm just going to divide both sides by 3. I end up with x is greater than or equal to -3. Now I'm going to sketch these. I've got some room over here, so I'm going to do it over here. Which number is smaller? -4. So the -3 is going to go on the right. Then I'm going to sketch x is greater than or equal to -4. That is going to be a square bracket opening to the right. Then I'm going to sketch x is greater than or equal to -3. So I'm going to put a square bracket opening to the right at -3. Where do the graphs overlap? Only this section here. So my solution will be all the numbers from -3 with a square bracket up to infinity. And if you check it, you pick something into that interval. What's something greater than or equal to -3? I don't know, 0. Is 0, so then you plug it into the original. So let's check something like 0. Right? Is 2 times 0 less than or equal to 4 times 0 plus 8? Is 0 less than or equal to 8? Yes. Then we plug it into the other equation as well because it has to satisfy both. Is 0 greater than or equal to -9? Yes. So we picked the values that make both of the equations true. So these are intersections with the word and.